So, hi everyone, welcome to the next video in our Verilog series. So, instead of starting with the topic name, today let us just discuss a simple problem which is there in the general Verilog code. So, let us consider there are two nets. So, let us consider there are two nets. For suppose, let us consider this is the output and let us consider this is the input. Okay. So still to be very precise, let us consider this is 0 and this is 1. So generally what will happen if both this are being driven to a same point? Then what will be the output? So we will be having a confusion. Even the tool will also be having a confusion. Why? Because you are driving the net multiple times. So which is called as a problem of multi-driven net. So here one thing for me to clarify is whenever we are considering the nets, they are nothing but either the wires or some other. Mostly we will prefer using the wires, even though there are so many variables, so many data types. So whenever you are trying to drive a net multiple times, so here from 0 will come and here a 1 will come. The similar scenario we have observed in the basic driver. So the tool will be unable to decide which one will win the race. So automatically the tool will throw us a don't care. So but instead that fearing that the output will be a don't care, this is not a right practice. Yes, a net has to be driven once. If you need another net, you need to have some comparison logic and you need to drive it. So you can't drive a single net multiple times. But you know what? How does the simulation react to this kind of the code? Let us check it. Instead me discussing it, let us just make a small discussion with the code. So as this initial target of this channel is to make the audience understand about different things in the Verilog, I'm not going into any complex coding. I wanted to explain everything in a very simple coding as possible. Okay, so let me consider a module and let me name it as test. And let us consider this is an end module. So let me consider there is a wire and let me name that wire as A. Let me assign the value of A equals to 1 here. Let us also try to assign the value of A is equals to B. See, there are two continuous assignment statements where you are trying to drive different values to a same net. Okay, so let us take the initial, begin and the end statement, and let me take hash one unit delay because of both the assignment statements will be working at the same time, and for that particular variable to get updated, because of we are having this active, inactive, NBA and finally monitor regions. So the dollar display is working in the active region only. At the same time, assign is also working in the active region. So just I'm trying to check the value in the next active region. So to make sure everything is working perfect. So this is nothing but dollar display A is equals to percentage B. I wanted to print a binary equivalent value. Okay. Now let me run this code. So if you can see that there are 0 errors, 0 warnings. And similarly, if I come down, you can see the output is don't care. The output is don't care, which is not what we have given here. Okay. So let me just copy the part of the code here. So here the output is nothing but don't care. Okay. So here we can tell that we are having an output of don't care. The output is don't care. because of confusion between 1 and 0. See, generally this type of statements are called as the procedural assignment statements, but these are the continuous assignment statements. If there is something inside the procedural assignment statements, obviously the first statement will be replaced by the second statement, but it's not in the case of the continuous assignment statement. So because all these values are continuously assigned, so that's the reason, in order to overcome this particular confusion, if there is a if the tool tells us that you have made a multi-driven error, so here we are getting the output as don't care. And one more thing is no warnings, no warning, no error, but wrong output. Why the wrong output? Because whatever we have given is completely wrong. So this is a very simple code. It's very easy for us to analyze. But if for suppose there is some thousand odd lines of the code, it will be very tough for you to remember. But we need to be very careful. But if there is a mechanism where the tool will tell us that you have made a mistake, the tool is going to shout at us that you have made this mistake, then it will be very happy for us. So that at least the tool will shout us, but the time will not be wasted. So Verilog designers or Verilog, the people who were writing this Verilog, the team has also found this issue of multi-driven nets, and they have given the solution for this in 2005 version of Verilog. In 2005 version of Verilog. So how they have given that solution is nothing but they have started a new variable called, new data type called uwire, which is nothing but unresolved wire. Okay. So we know the problem. The problem is before us. So let's directly try to use this uwire. Let me save it and let me run it. So have you seen the error in the fifth line of the test bench? That is this line. It has said that net A is of wire U wire type, cannot be driven by multiple drivers. So it is telling that the net cannot be driven by multiple drivers. So it is telling that the net cannot be driven by multiple drivers. So which is what the same issue which we have faced earlier. So this unresolved wire was really a very big advantage for us whenever you are writing a Verilog code. But so now I think we are very good to understand what is the advantage with the multi unresolved wire. It resolves the problems of multi-driven net. Okay. So by considering the importance of the same idea, they have used it in system Verilog even. In system Verilog, but in the system Verilog, they appended the same idea to the logic data type. So in the system Verilog, instead of using the reg, or instead of using the wire, or instead of using the U wire, all these three properties together will be combined in a single data type called as logic. So that's how they have solved a very big issue. So thanks for watching this video, and please do like, share and subscribe to Beacon Preceptor for very short contents and short videos related to the Verilog as of now. But in future we are having a plan of working on multiple things. But please do comment below, and if you are having any ideas also, please do comment below. We are ready to make that required videos. But thank you. We'll meet you in the next video related to the next Verilog content. Thank you one and all. Thanks for your patience.